Hi everyone, welcome to this video. We're going to talk about the theory of consumer's choice. This is the chapter 21. This is the book Principles of Economics, 7th edition, a book of Gregory Mankiw. So first, it's important to locate in the situation that we are going to present throughout this chapter. Let's imagine that you are going inside a supermarket and naturally you need to face a decision. You need to get a choice. So the point is like what to buy, taking into account price and preferences. Obviously, you really want to eat like really nice food, but unfortunately, maybe due to the prices, that's not possible. So then, we know that before in the previous chapters, we have summarized consumers' decision throughout consumer demand. And then at the end of the day, this demand curve that we had a look before, it reflects the willingness to pay. So naturally, when we think about law of demand, we think about when price rises, naturally the demand will go down. This is the normal standard of law of demand. Naturally, some goods and services they don't work at this, but naturally is that the usual. So we will have a look more in the decision behind that. Obviously, we know because of the 10 principles of economics that naturally people face trade-off. You cannot watch this video and at the same time play soccer. It's almost impossible. So you cannot pay 100% attention to this video and 100% attention to Facebook. So that's the part. Then we go into the first concept of this chapter, the budget constraint. The limitation of your money is naturally what the consumer can afford. So obviously people most of the times they consume less because they're constrained. Here the situation that we're going to analyze during this chapter. Imagine that we have two goods. You can imagine whatever you want. Obviously, the idea is like this should be that maybe you eat one of them in the presence of the other. It's not really easy to consume one to another. Well, they are kind of, in some way, there is kind of a complement, more or less. So here we are assuming just two goods in the economy. Imagine that you have an income of $1,000 per month, and then during this month you will consume all that just in pizzas and Pepsi. Obviously, the person should spend completely the money, cannot put away anything. And here we have the articles: $10 the pizza and $2 the Pepsi. Then naturally we can build this table. First we have here the number of pizzas and here the liter of Pepsi. So naturally we are assuming that this Pepsi can, it has 1 liter of Pepsi. So here we have the consumption. Why this combination? Because imagine that you consume 100 pizzas times $10 each pizza, you will get 1,000. Then 90 times 10, 900, so on, so forth. Until 0 times 10 should be 0. Here with Pepsi exactly the same. You will have 50 times 2, you will have 100. So when we add all of these values, the total spending is the total money that you have. So here we have built different bundles of pizza and Pepsi that they will bring the total budget that you have. So with that information, you can build or you can graph the the budget constraint. How you need to graph that? First, you need to identify the x's. Why do we put pizza here or Pepsi here? To tell you the truth, it doesn't matter. You can make upside down. It doesn't have any importance. But here we have chosen in that way. Then here is the quantity of pizza and quantity of Pepsi. This is measured in liters of Pepsi and the quantity of pizza in slices of pizza. So here is the budget constraint. And here the point B, it represents that you consume all in Pepsi because you will consume the maximum 500, so you will be over here of Pepsi. Well, I'm sorry, here, over here. 500 liters of Pepsi times time 2, you will get 1000. So obviously you cannot consume anything in pizza. Here the other case, you will consume all your income in 100 in pizza, so you will get 100. So we are here times 10, you will get $1,000. So this is like the two opposites where you consume so extreme values, and all these are the combination of them. Due to the relationship between them, it does not change, is what we call constant slope. So then in order to graph it, you just need to identify the extreme points and you can join them with a straight line because this is a constant slope. And C is a point which represents 250, so half of Pepsi, and 50, half of the pizza that you can get. C is the middle point, as I said before, and the other one is all in pizza. So a slope of 2 points is measured as the change in the vertical distance over the change in the horizontal distance. So change in y-axis over change in x-axis. So here we have the quantity of Pepsi, quantity of pizza. So you just need these 2 points, you join them, and this is the budget constraint. So here we have the quantities, so you can express the slope as the change of y over the change in x. So y is Pepsi. So in order to understand better, Pepsi 2 minus Pepsi 1, pizza 2 minus pizza 1. Here is the first pair of point is going to be x equal to 100, y equal 0. This is our first point. The second one is going to be 500 in y, and in x is going to be 0. So then Pepsi 2 we represent as 500 minus Pepsi 1, which is going to be 0. And the other one, pizza 2, should be 0, and pizza 1 should be 100. So then we have 500 over minus 100. We can cancel out these zeros, and we can express better as minus 5 or minus 5 over 1. Then, here is the slope of this budget constraint. This is the measuring y, so then should be measured in Pepsi, and 1 should be measured in pizza. So then this slope, it contains the information of opportunity cost. Why? Because you can give up 5 Pepsis for having 1 pizza. Why? The cost of 1 pizza is $10, and the cost of 1 Pepsi is $2. So 2 times 5, it will bring 10, which is exactly the price of pizza. So this slope represents the change, the monetary change of this budget constraint. Then, if you want to go deeper to this budget constraint more in mathematics, you can click on this on the video of how to make a budget constraint. So the preferences, we already constructed the budget constraint. Then, obviously, this is just monetary, but we need to complement with something else. So this is what we are going to talk now, the preferences. So the preferences, what the consumer wants, representing preferences with indifference curves. So we know that the budget constraint just shows the combination of prices and quantities but no preferences. Then consumer preference allowed to choose among different quantities of picks of Pepsi. So then, along all the bundles that you have available due to your constraint, you will choose the one that will bring you like more satisfaction. This is the idea. So if you go to the supermarket and you have just pizza or Pepsi, maybe you are not going to choose just pizza because maybe you will get thirsty. But otherwise, you will not drink too much Pepsi because otherwise you still will be hungry. So then you can start how usually in general consumer people prefer like medial or central points where there is a combination among the two goods. So if consumer has the same tasty, we say that these two bundles are indifferent. So when we compare two bundles of different quantities of these two goods, and you say, okay, which one you prefer, this one or the other one? And you say it doesn't matter. Both are okay for me. So automatically it means that the consumer is indifferent to these two bundles. So, and we can represent in a graph the indifferent curve. These indifferent curves represent various bundles of consumption that make the consumer equally happy. So throughout all this curve, you cannot say I'm better here or better in this other point. You will be equally happy all this curve. And the quantity of Pepsi that make you equal satisfied. So then, here we have the same axis, quantity of Pepsi and quantity of pizza. So this is our normal indifferent curve. And we're going to analyze why is that shape and what are the properties of this one. So here we label as I1 indifference curve 1. This is indifferent curve 2. So all the time that we have like outward and indifferent curve or more to the right, you would say that I2 is preferred than I1. Why? Because this indifferent curve in all the points, it has more quantities of Pepsi and pizza than I1. And we assume that people prefer more than less. Then here we have one bundle, which is C. And here we have another bundle. We label B, this one A, and this D. Second, C is indifferent to B. Why? Because they are in the same indifference curve. B is indifferent to A. Again, all the bundles that they are in the same indifference curve, they are indifferent each other. What about if we talk about C and A? Again, they are indifferent as well. What about D? Naturally, B is preferred to A, B, and C. Why? Because D is located in indifference curve 2, and indifference curve 2 is preferred than indifference curve 1. So this represents quantity of pizza B, whatever, and quantity of Pepsi B, any quantity. And this is the slope. Remember that we already saw the slope of the budget constraint, but we are going to explain a little bit more that. And the slope, different from the budget constraint, you remember it was constant. Here the slope is not constant. Here you see that it's steeper than here. Here is kind of flatter. Then this slope changes, and this slope is called the marginal rate of substitution. Then this is different. Here is the marginal rate of substitution. We can define this as the rate that which is willing to trade Pepsi for pizza. So this is the slope of indifference curve. Basically, how how many slices of pizza I need to give up to get one quantity of Pepsi, but still I remain the same satisfied. So I still receive the same satisfaction. What is the compensation? If you take me out 1 liter of Pepsi, what is the quantity that you need to provide to me in order to be in the same level of satisfaction? So we usually we say that in absolute value. Remember, absolute value is that you just take the positive values. You don't take into account negative ones. So imagine B. B we assume that is 1. The other one we assume that is 1/5, and the other one we assume that is 5. But why I came with these numbers? They are artificial, imaginary, just to represent some numbers to get like a little bit more clear that situation. B is 1. So it means automatically that at this point, the middle point, you value the pizza equal than Pepsi. Take out the price. You just think now about preferences. So you value exactly the pizza equal than the Pepsi. It means that you will trade one pizza, one slice of pizza for 1 liter of Pepsi because you value exactly the same. Why here A? You value 5 times Pepsi compared with pizza. You will change 5 pizzas for 1 Pepsi. Why? This is naturally don't try to learn that by heart. Try to just make logic here. Imagine that you have a huge quantities of pizza. So you have a lot of slices. Naturally, you get thirsty. So due to that, you are willing to change this one at that part. You value 5 times Pepsi because you are completely thirsty. So you can change 5 pizzas just for 1 Pepsi because you really value a lot. The other part is completely the opposite. You have a lot here of liquid, a lot of Pepsis, but you still are hungry. So then you make the opposite than a situation. You change a lot of here, you value more pizza, just you can change 5 Pepsis for 1 pizza. So this is the idea for why this is the shape of the indifference curve. Because obviously you prefer medium points when you can trade or you value both goods at the same rate, and the other part they are extremes when you can give up a lot just to get one of the other good. What are the properties of indifferent curves? So there are 4 mainly. The first, higher indifference curves are preferred to lower ones. That's logic. We saw before, people usually prefer to consume more goods rather than less. Higher indifferent curves represent larger quantities. Second, indifference curves are downward sloping. Why? Because it reflects the rate at which one consumer wants to substitute one for another one. Because you give up for one to take to another one, you would say that this is downward sloping. If one is reduced and the other should increase, it is negative, then it's downward sloping. Third characteristic or property, indifference curve does not cross. Here we start with the fact that imagine that they cross. So here we have the 2 indifferent curves. They violate the property 3, but we're going to use that as a fact because this is incorrect. If there is a contradiction in this fact, we will automatically go back and say, okay, this premise is false, then indifferent curve, they don't cross. Here we have 3 bundles. In order to make that, we need to put in the cross section B 1 bundle and these other 2 bundles. First, A is in the same curve that B, what we have said before. If two bundles, they are in the same curve, we can automatically say that B should be indifferent to A. If we are in the two part, the second situation is B in the same curve than C, right? So then B should be indifferent to C. If we mix these two situations, want to imply that that should be equal, that A should be equal preferred to C, because this is indifferent to this. This is indifferent to C. So then this should be indifferent as well. But definitely this is false. So we go back to say that the indifference curves don't no cross. So in contrast to the fact the consumer always more more goods than less. Obviously, because here you have more of these two goods, and you say that this is equal to A, it doesn't make too much sense. So here we have the same scheme, but we put numbers here of the marginal rate of substitution. This is naturally steeper, so this is a larger number to this one. So here this is a property 4. Indifference curves are bowed inward. The slope of a different curve is the marginal rate of substitution. And remember that the marginal rate of substitution depends on the place where the consumer is, because this is not constant. Then here we have for example 14 Pepsis for 2 slices. And here you have 8 Pepsis for 3 slices. Here we have the next situation, 7, 6 pizza, and then 3 and 4. So this one is the situation. You make the difference of 14 minus 8 should be 6 over the change in x, which should be 3 minus 2, which should be 1. So for this reason, the marginal rate at the point C should be 6. This one, you have the change in y, 4 minus 3, 1, and the change in x, 7 minus 6, should be 1. So for this reason, the marginal rate at this point is 1. So then, in the sixth part, you are more hungry than thirsty. And in the second one, you value both the same, may more thirsty than hungry. So actually, you are in the same position. So the bowed inward implies that you value less when you have more of a good. So this is one of the characteristics of the diminishing consumption rate, right? Because when you eat more, when you drink more, then the additional consumption that you get automatically will represent less satisfaction. Then, what the consumer wants, 2 extreme examples of indifferent curves. We already saw that for normal goods, that you always want more from one to another one, and you combine them to have more middle points. Here we have the situation when the goods are easy to substitute for each other, the indifference curve is less bowed. Why? Because when the goods are hard to substitute, it is more bowed. We will see that in order to understand better. So here's the situation of perfect substitutes. We have this one, which is 1 nickel. It represents the value of 5 cents. And we have here 1 dime, which it represents 10 cents. Those are perfect substitutes. Why? Because you always will trade 2 nickel for 1 dime. So it's not like Pepsi and pizza that they're kind of complement because you're hungry or you're thirsty and you need to mix them. No, actually you can get all of nickels or all in dimes if and only if they represent the same value. So then we can assume they are perfect substitutes. What about perfect complements? Bundle of shoes. You just care about pairs of shoes. Imagine that you have 5 right and 7 left. It doesn't matter to you. You don't care. You just want the pair. So then the yield should be 5 pairs. It doesn't matter these 7 ones. Then The perfect substitutes will represent in that way. This is nickel and dime. So then, here is the extreme. You will have 1 dime is exactly equal to have 2 nickels, because 2 nickels, they are 5 cents and this is 10 cents. So the point 2, no, the point, sorry, 0.2 is strictly preferred, is exactly indifferent to 1.0 because both are the same. When you join them, this is the indifferent curve. As you notice, this is equal to the budget constraint in one way. The slope is constant because you want to change 2 nickels for 1 dime all the time. Okay, so this is the indifference curve. Here, imagine that we have 2. What is the indifference of having 2? Naturally, 2 times 2 should be 4. So this is another representation of the indifference curve. The other one should be 6, 3, and this is the other one. So this is a constant slope, as you noticed. So the change of y over the change of x is constant all the time, different to the marginal rate of substitution that we saw before. So then y should be the change in nickels and the change in dimes. This one all the time you have 2 and 1. Then perfect complements, you have left shoes and right shoes. You can get 1 and 1, or you can get 10 and 1, and it doesn't matter. It values exactly the same for you that 1, 1. So then if you have 1 million of right shoes but you just have 1 of left, this is constant. So this is exactly the same value. So for this reason, this is the indifference curve. Similar to the part of this, that you have 10 left shoes and then 1 of right shoes. You don't care about these other 9. You just care about the pair. Here we have the other situation, 2 and 2, and so on and so forth. So the characteristic here is that you are talking is that 90 degrees the angle of this indifference curve, right? And recalling, this point is strictly preferred than this point, and this point is exactly the same as this one. However, this point is preferred to this one. The same here. This point is exactly indifferent to this one or to this one, but this indifference curve represents higher satisfaction than this one. Then the consumer's optimal choice. So we already have the budget constraint and we already have the preference curves. So we need to join these two pieces. Then how much she can afford and what she wants to spend. So the consumer would like to end up with the best possible combination. So it could be the case that end up on or below the budget constraint. Then here we have the quantity of Pepsi and here we have the quantity of pizza. This is one indifference curve, this is another one, and this is another one. I3 preferred to I2 and I2 preferred to I1. So here is the budget constraint. So as you notice, all these points that they are below the budget constraint, you don't spend the total amount. But if you are out here, you cannot reach those points because you cannot afford them. So then the situation is that this exactly point, when you touch the higher this should be the best situation. Then this is the quantity optimal of pizza and the quantity optimal of Pepsi. What about B part? As I said before, this is point below the budget constraint, and A, this point is out of the budget constraint, is not reachable. Right. So then the optimal that you verify here, the slope of marginal rate of substitution is exactly equal to the slope of the budget constraint. So this is like tangential between these two curves. Then this one is the fact of optimal. So this is the point. I would like you get the general idea of that. Obviously the mathematics we will go after, but first it's important to grasp the general idea of that situation. So then the slope of the difference curve, as we saw before, is the marginal rate of substitution. And the slope of the budget constraint is the relative price among Pepsi and pizza. Thus, the consumer chooses consumption of the two goods so that the marginal rate of substitution is equal to the relative price. So the relative price is not more than the ratio of the price of one good over the other good. So this is a section that for your information of the book. Another way, that an alternative way to describe preference optimization. Obviously, we know that these preferences or the difference curve, they have attached the concept of utility. And utility is an abstract measure of the satisfaction of happiness that a consumer receives for a bundle of goods. Why is that abstract? Because it's not a certain measure. Because you cannot say like 1 meter and 2 meter or 1 kilometer, 2 kilometers, which is something a fact. Utility is something abstract. I cannot compare the utility that you have with the utility that I have when I'm drinking a Coke. We just say that one is more. For example, I like more juices than sodas, but maybe another one likes more sodas than juices. But we cannot say, okay, my utility is 5, and then the other says, okay, my utility is 3. What about you? It's really abstract. It's not obviously easy to make something countable. However, we know that something you like more and something you like less. You can compare them. Then a consumer prefers one bundle to another if it provides higher utility. An indifference curve returns the same level of utility. So we say that this is an equal utility curve. Then the marginal utility is the additional utility you get for an additional unit of that good. We have seen that before. And most goods are assumed to exhibit diminishing marginal utility because naturally when you drink the first glass of water it represents a lot of utility, but maybe the fifth one you don't want to drink more water. Then the optimal point is when the marginal rate of substitution is exactly equal to the relative prices. And obviously the marginal rate of substitution depends on marginal utilities. If the marginal rate of a good X is twice the marginal rate of Y, so it means that you need 2 units of Y to compensate for 1 unit of X. So then the marginal rate of substitution should be equal to 2. Then the marginal rate of substitution is basically the ratio of the marginal utility of X over the marginal utility of Y. So then we have this one. This is the relative prices. As I said, the ratio of the prices, Px over Py. Then the marginal rate of substitution is marginal utility of X over marginal utility of Y. So you just can collect them. This is on the one side, go to the other side, dividing, and this one go to the other side in the numerator. So then the concept is like the marginal utility per dollar spent should be the same. So it's like this marginal utility of each basically of each good should be exactly the same. Naturally, if this equality does not hold, you will consume more until you get the same marginal utility per dollar of both sides. So then, imagine that here we go to different situation of the optimization. So how changes in income affect the consumer choice? So this is the optimal 0. Now imagine the situation that income increases. So imagine the situation that Pepsi is an inferior good. What is an inferior good? It's a good that when you earn more money, you consume less. Should be kind of difficult to think about that, but normal example is buses. This is an inferior good because when you have more money, you will change them for taxi or for your own car. Then this is the shift of that curve outward, and naturally here is the situation. We represent these two indifferent curves. It's important to notice that your slope, it does not change, because remember that the slope of the budget constraint is the relationship of prices, and the prices, they have not changed, so then the slope should be exactly the same. You just will consume more of two goods. Then this is a situation. You will consume more in pizza and less in Pepsi, right? So for this reason, this situation when Pepsi is an inferior good. Then imagine the other situation. We already moved the income. We already noticed that if it increases, it go to the right with the same slope. If it decreases, it go to the left. In the previous example, we represent that Pepsi consumption will decrease, but this is not all the time. It could be the case that it could be a normal good, and then the Pepsi consumption will increase as well. So imagine that the price falls from 2 to 1. So remember that the price was $2 of Pepsi. Then this fall in the price of any good shifts the budget constraint outward, because you are kind of between quotation mark richer in that good. You can buy more of that good. So then your income is 1,000. Your price of pizza is 10, and now your price of Pepsi should be 1. Before, you could consume 500 because the price was 2. Now you can consume 1,000 if you don't consume anything of pizza. So this is the situation now of the budget constraint. Naturally, you will reach a higher indifference curve. You will be better off, and this should be the consumption of Pepsi. Okay? Then, and this one should be the consumption of pizza. As you can notice here, your consumption of pizza decrease, right? Then, just in the case that consumer spends all in pizza, the change is irrelevant, because both situations are exactly the same, because the change of the price was in Pepsi good. Then the slope changes. As you can see, this is steeper, right? And just to have like maybe something here is like, you know that this slope is given by the change of y over the change of x, right? This one increases, right? Because this is cheaper. This exactly we said that remain the same, but these go up. So for this reason, this is steeper, right? Because of the change in Pepsi. Then, what the consumer chooses: income and substitution effects. Okay. Then we know that the impact of a change in price can be decomposed in two effects: the income and the substitution effect, and the sum of them will give us the total effect. So due to the fall of the price, consumer can buy more pizza and more Pepsi. So this is the income effect, right? Because of the fall of that price. But also, due to the fall of the price of Pepsi, I can give up more pizza. this is relative more expensive. Why? Because Pepsi is cheaper. So before it was the relation like 5, right? 5 times 2, 10. Now the relationship is like 10. So then you will have in some way less pizza and more Pepsi. So this is the substitution effect. And when you add both, you will get the total effect, and this will bring us if the consumption of that good increase or decrease. So to define that, the income effect is the change in consumption that results when a price change moves the consumer to a higher or lower indifference curve. Here, for example, here we have the situation. Income effect. Because of the Pepsi price falls, consumer is richer, so she buys more pizza. This is the income effect. In Pepsi, should be exactly the same. Consumer is richer, so she buys more pizza. Why, right? Because the Pepsi price went down. What is the substitution effect? Pepsi is relatively cheaper. Relatively, what does it mean? It means that compared with pizza, obviously cheaper, because before it was 5 per 1 and now it's 10 per 1. And then pizza is relatively more expensive, so consumer buy less pizza. So from one side, more, for the other side, less. So it depends of this change, what should be the total effect. Here, more and more, so definitely the total effect, they are in the same direction, so consumer buys more pizza. Here could be ambiguous, so it should be the case that you will end up with higher quantities of pizza or maybe with less. So it depends, because if this income effect would make you buy more pizza is higher to this substitution effect, naturally you will eat more pizza. If that's the other case, you will consume less pizza. Then, here we're going to decompose, and this is extremely important that you understand well. Here we are this initial situation, optimal point where the slope of the indifferent curve is exactly the same as the slope of the budget constraint. Imagine the situation that the price of Pepsi decreases. Here you have naturally that because of that you can consume more in Pepsi, and in this case the budget constraint is cheaper, and it makes you the possibility to reach higher bundle of Pepsi and pizza. So you are better off definitely, because this triangle you didn't have before, and now you do, right? So then here is the indifferent curve. Here is C, and here is the situation. So we're going to discuss about the decompose the total effect. As you notice, the quantity of pizza decreased. Why? This should be the case because one effect was higher to the other one, right? So then definitely the income effect will the substitution effect was higher than the income effect. So here the case, this is the total effect. So to see the income effect, the easiest way is basically go to with the same slope to the original indifference curve. So you move this curve parallel to this other indifference curve, and you will find a bundle B. So this difference BA, this will provide the substitution effect, right? Here is the substitution effect. This one was A to B, which was negative. And due to the income effect, remember, due to that situation you are rich, this is positive because you will consume more because you are richer. But due to the relativeness of the Pepsi price, naturally you will consume more Pepsi than pizza. So this is the substitution effect. So then this one is higher than the income effect, and naturally the result is the total effect, which is negative. So total effect is like the conclusion, right? The income effect is all the time the bundle that you will have if you have the same prices to the previous indifference curve. So this difference between B and C. So then, now we are going to analyze Pepsi, that we already knew that those are positives. First, the total effect you pass from A to C. So this is the total effect. Then, this one from A to B we can mention as the substitution effect, and this one the income effect. So this is easy recalling. First, you have this situation, right? This situation. The price decreases. Then you have this one, the new budget constraint, the new indifference curve, you are now on C. So this is the total effect. You need to decompose it. First step, go to the order to the previous indifferent curve parallel with the same slope, and then you will reach a bundle B. So then the difference between these two bundles BC is what we call the inference income effect, and the other one, the substitution AB, should be the substitution effect. And because substitution effect is higher than the income effect, the total effect is negative. The other one, you have again the total effect, you come from A part or A quantity of Pepsi to C1. Then from A to B, this is already draw, so you will take that from A to B should be the substitution effect. So then you substitute them because relative Pepsi is cheaper than pizza. And income effect because you are richer. So that's the case. Then the demand curve reflects the change of consumption due to changes in price. So here we have the situation. Here we have an example that we have before. Imagine 250 and this point to 750. Then with a price of with the quantity of 250, the price was 2. When the price decreases to 1, the quantities increase to 750. So from this situation, we can go here. Remember, y is the price of Pepsi and this is the quantity of Pepsi. We have P and Q. So we can infer from the situation of the theory of consumer choice, you can go to the demand curve. So we are going to see here 3 application and then do all demand curves slope downward. So when a good price rises, people buy less of it. This is natural. So this is reflected in the downward slope. But however, sometimes demand curve can slope upward. So it means that when the price rises, the quantities rises as well. So in that sense, consumer can violate this law of demand, so then buy more when a price rises. So here is the situation. Imagine that here we have the quantity of potatoes and quantity of meat. Imagine that we are here in the situation A, the optimal, when the slope of the margin of the indifferent curve is exactly the same as the slope of the budget constraint, which is the relation of prices. And here we have the situation B. Imagine that B was the initial, A was the initial situation. Imagine that the price of potatoes increases. Then this B situation, you see here that you have more potatoes, right? Why should be that the case? This is an example of something that it really happened. Potatoes were given good. What is a given good? A good that when the price rises you consume more. It was a given good during Irish potato famine of 19th century. Why? Because in Ireland potatoes were important to the diet. So people start to consume less luxury meat and more potatoes because now the meat, it was really expensive. Now imagine that they are even more expensive. So naturally, even the potatoes increases the price, you will consume more of them. So then it should be the case of a given good. So how do wages affect labor supply? We know that we have a trade-off here again because we can use to find how people allocate time. There is a trade-off between leisure and consumption. Suppose a person that is awake 100 hours per week. So we're counting like 7 days a week. So this should be something related with what? Like 14, something like that. So 14 hours per day should be okay. Then for every hour she earns $50. So the wage, $50, reflect the trade-off between leisure and consumption. Why? Because if you don't work, you cannot get that money. You will consume that. Then we have Y consumption and hours of leisure is X. Why you allocate them in that way doesn't matter. You can locate the other side. It's okay. So then we have here 105,000. Why? Because here this is measured by hours of leisure. You cannot work anything, so you will get automatically 100 hours of leisure. But obviously you will get zero of consumption because you will not get money. Otherwise, you can use these hours 100, and by time of $50 per hour, you will end up with $5,000 of consumption. So this is the trade-off. Obviously, you would like to get more of them, but you cannot. So here is the one example that you get 60 hours and $2,000 of consumption. Here is the budget constraint, which is constant slope. And here is the maximization, the optimal, right? Then imagine that we are here in the optimal one. And here we know that the wage changes from 50 to 60. This is kind of the price, the price, right? So here we have the situation. Now, if you work exactly the same amount of hours, you will get this value. It will increase, right? So at this part, you will get a higher indifference curve, will get more consumption, but here less hours of leisure. So it means automatically, because the wage increases, so the hours of labor supplied increase as well. So for this reason, we get here like the relationship between wage and hour of labor supplied. So this is the situation. Why about this is one like model of preferences. Imagine that this is the other guy, that due to the wage changes from 50 to 60, now this person will not work more. Actually, this person will have more time of leisure. So then for this person, the relationship between wage and hours of labor supply is negative. So this is really interesting because the normal thing is like if you get more money, you will work more, right? But that's not the case. Here is summarized. They are summarized both situations. What are the difference? The wage increases obviously, but this guy will work more naturally. This imply less hours of leisure, and the other one will work less. Then this person will have more hours of leisure. Then, due to higher wage, she earns more consumption for every hour of leisure that she gives up. Obviously, because at that point, at that time, you can have like higher salary. So then this should be the case. She earns more consumption for every hours of leisure that she gives up. Because if you give up 1 hour and you work before, you have $50 and now you will have 60. So that's the part. So consumption increases but in different way, right? Because this one consumption increased here, this consumption increased but not as much as the previous one. So then we have here one situation, less leisure, and the other one, more leisure. So then we're going to discuss this one because it's this one that is more interesting. Why, if you receive more money, you work less? Then, because leisure becomes most costly uh, relative to consumption, right? It becomes more costly because you receive more money. Then this is encouraged to change consumption to leisure. This is the substitution effect. Then that you say, okay, if I give up 1 hour of leisure, this will cost more than before. So this should be kind of negative one. But then the other part is the income effect. She tends to have more of both. Those are normal goods. Obviously, this person will have like higher well-being. So then, if this substitution effect is higher than the income effect, then she will work more, right? But if the substitution effect is lower than the income effect, she will work less. So people that maybe they value more money, they will value it, or they will have more substitution effect than income effect. And the person that prefer like well-being to have more of both, they will end up with the substitution effect lower than the income effect. So then, this is the case. We have the consumption hours of leisure. So the part here, in order to understand that, because maybe it's not easy to go to the reality, is like before 100 years ago, people worked 6 days a week. And now usually people work 5. The wage has increased adjusted by inflation. So this is the case. So advances in technology has increased the productivity of workers. So for this reason, they will have like higher salaries, and this increase has ended in higher equilibrium wages. And then at the end of the day, they have more time available for leisure. So for this situation, the income effect dominates the substitution effect, right? So then one important thing is lottery winners. So the budget constraint shift outward. This is the case. So they will end up with a part of more consumption and more hours of leisure. This doesn't change because the change was an external, was like salary, and so you will have like more of them. So there is no substitution effect. All is income effect. Then a case study of income effects on labor supply. So some interesting study of the historical trends of lottery winners and the Carnegie conjecture. So winners of more than $50,000, almost 25% quit working for 1 year, and 9% reduces the time they work. Then the winners of more than 1 million, 40% stop working. Similar travel with a bequest. Likely people will stop working and they will have less worthy and useful lives because they will just depend on the bequest. So this is the situation of the Carnegie conjecture, and actually he just donate his money, because if this was a bequest to to their son, or to the son, so naturally this person will not work. So then for this reason, like the Carnegie conjecture, I will give you money, but then everything will be so easy and you will not struggle for that. Then the other part, how do interest rates affect household saving? Before we just think about a present consumption, but we can make the same analysis or take the basis of that analysis to understand a trade-off of consuming today or saving to the future, which is naturally consume in the future. So imagine Saul, who is planning for retirement. In the first period, Saul is young and working, and he earns $100,000. In the second period, we assume that he's old and retired. So he divides his income between current consumption and saving. When he's old, he will consume what he has saved, includes the interests that his saving have earned. Okay, so this is the difference. Suppose that the interest rate is 10%. So then it means that for each dollar he saves, he will get 1.1 US dollars when he's old. So at the end of the day, the interest rate determines the relative price of these goods. So here we have the two situation: the consumption when old and consumption when young. I, which is the interest rate 10%, your salary is $100,000, and this is your constraint. So you can consume everything when young, it should be $100,000, or you can consume everything when you are old, $110,000. So this is the budget constraint. And this is the medium point, the optimal one, which is the medium of that, and the medium half of that, I have the other one. So then, this is the situation. So imagine that the interest goes to 20%. So naturally, this is like you have like more temptation, or you will have more consumption when old, right? Because instead of 110, you will have 120,000. So then this is the same situation. Here, naturally, you will have the green one, which is the expansion of your budget constraint due to the increase of the interest rate, which is kind of the decrease of the price, right? So then, here, this is the situation. Now we have two possibilities. One, that you consume when young less, or you consume more when young. So this is the part. Then we are going to analyze the one that is maybe not natural, because previous one you say, okay, if I will get more when old, I will save more, right? So then I consume less today. But this should be the behavior that you can save more when young. And why, if higher I save less? This is because the substitution effect, because consumption become less costly relative when young. It induces to consume more now. This is the substitution effect, right? Because it's not a really high cost to consume now. So then it induces to consume more now. But the income effect, he goes to a higher indifferent curve, and there is a better well-being, having more consumption in both periods. So then this is the part. If the individual think that the income effect is higher to the substitution effect, this one, he will consume more. If the other side, the income effect is lower than the substitution effect, so this is the part. So consumption become less costly relative when young. So then that should be the case. Income effect lower to the substitution effect. So the conclusion, do people really think this way? So then the important part is like the theory of consumer shows how people make decisions. So then you can find different scenarios. Two goods, maybe you can think about work and leisure as we saw, or consumption and saving. So this is a model, and this is not 100% realistic. As we said in the chapter 2, think like an economist. As economists, we try to modulate the reality in something the easiest possible, because we would like to understand the basic facts. If we start to put more variables to make like real one, we're going to lose the detail or the fact that we are trying to find. So that's all. I hope that you have enjoyed, you have understood this basic idea. Obviously, we jump or we skip all the mathematics just to understand. This is the principles of economics. And obviously, ahead you will be more, but this is especially important because if you don't understand that, if you go to math, you will get crazy. That's all. Thank you for watching my videos and see you the next time. Bye bye.